So if I gave you this equation right here, x cubed minus 8x squared plus 11x plus 20, how would you try to solve this? Like by grouping, right? Okay, absolutely. So does anyone see a problem with that? Well, that's what we're trying to do. We're trying to solve it. So it's going to be equal 0 or equal something if we're trying to solve it, right? But we're going to try to solve it by doing something to this side to get it to its factors, because once we have it in its factors, I can easily solve it, right? Okay? But if I am trying to solve it by grouping, do you see a problem with that? Like if I'm just trying to start doing it in my head, what's common here is x squared, right? What would be left over is x minus 8. What do I divide out between these two to get x minus 8? Ugh. So does grouping always work? No, we got to have a plan when grouping doesn't work. Okay? So here's the plan. The plan is called rational root theorem. Okay? The plan is called rational root theorem. I'd like to show it to you, and then I will translate it into English. Okay? Here's the rational root theorem right here. See where it says core concept? Rational root theorem. If f of x equals a to the n, a sub n x to the n plus dot 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 plus a sub 1 x plus a sub 0 has integer coefficients, then every rational solution of f of x equals 0 has the following form. Blah, 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 blah. Okay? That's the rational root theorem. It's actually a pretty important theorem. Okay? But let me please translate it into English now. The rational root theorem says if this is my equation that I'm trying to solve, if it has integer solutions, coefficients, like these are right here, then I can find the solutions or the factors by looking at the factors of P divided by the factors of Q. Now, I know we talked about the other day this being A and this being C. I know we did. Okay? Sometimes people in math just change the letters on us for no reason. And we just got to go with it. Okay? So here's the pattern. This may or may not make sense to begin with. I want you to learn the pattern, and then we'll learn how it makes sense. Fair? Okay, so first thing we do is we look at the very last term. In this case, 20, right? And we think of all of the factors of 20. Remember, rational root theorem says we got to do P divided by Q, right? Well, what are the factors of 20? 1, 2, 4, 5, 10, and 20. Are there any more, or is that it? That's it, right? Okay. Except what about the negatives? What two numbers multiply to be 20? 1 and 20, right? But what else? Negative 1 and negative 20. So I actually have to think of positive and negative 1, positive negative 2, 4, 5, 10, and 20. Divided by all of the factors of the first number. Well, we kind of lucked out here. What's the first number? 1. Plus or minus 1. So what's anything divided by itself? So I end up with 1, 2, 4, 5, 10, and 20. Okay? Excuse me. These are the possible numbers that I can get my solutions from. How many solutions should I have? Do you remember the fundamental theorem of algebra? Fundamental theorem of algebra says whatever my degree is, which is my highest exponent, that's how many solutions I should have. So how many solutions should I get to this problem? 3, okay? Now, that's not always how many factors there are, but that's a discussion for a whole nother day, okay? But I should get 3 solutions. You ready? Well, 2, 4, 6, 8, 10, 12. I have 12 possible things to try, and I know only 3 of them are going to work. Okay? And so you might think, oh my gosh, 12 is so many to try. Except, what's my other option? Yeah, infinity. I have an infinite number of numbers that I could try. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way to infinity. And then the other direction, -1, -2, -3, all the way that way. So having just 12 seems to be like super easy, right? So here's what we're going to do. I hinted at this when we talked about it before, and I said to you, we're going to talk about this later. Well, guess what? It's later. Yeah. Okay. So here's what we're going to do. I'm going to start with 1 because that's the beginning, and it's kind of a good place to start, right? I'm going to start with 1. 1, -8, 11, and 20. And I'm going to do some synthetic division. Remember this? Yes. 1, 1, -7, -7, 4, 4, 24. Okay, so I've done synthetic division. What does that mean? Do you remember when we did synthetic division and I told you something was really special when something specific happened? There was a special situation. When my remainder is 0, what I had was a factor. And right now we're trying to factor this so that we can solve it. Okay? So did this tell me anything? No. In fact, what it did tell me is that 1 is not a solution. Right? So what would be the next number I try? How about -1? Okay? 1, -8, 11, 20. 1, -1, -9, 9, 20, -20, 0. Okay, so what does that mean? -1 is a solution, right? It's okay. No, that's okay. Those two words, sometimes people think are interchangeable, factors and solutions, but I will make sure you know the difference here in just a second, I promise. Okay? So here's an interesting point. I know that -1 is a solution. I've got to find how many more?